Hello and welcome to this online video lecture about the correlation between certain types of bonding and properties of the compounds that have that type of bonding. We find that ionic, polar covalent, and nonpolar covalent substances often follow a pattern in terms of their properties because of how the molecules are created or the ions are arranged inside the substances. So what I've done here is I've arranged a little table. You might want to, if you're taking notes, you might want to pause the video so you can write this stuff down or copy the table before I get going. But what we're going to do is we're just going to go through and fill this table out, and I'll probably do a row at a time instead of a column at a time. So we're going to start with melting boiling point. Ionic substances have very, very high melting and boiling points, and the reason for that is because the attraction of the negative and positive ions is one of the strongest attractions that we find in chemistry. So you can melt and boil ionic substances, but you have to get them very, very, very hot before you can do so. Now, polar covalent substances, in terms of ionic substances, their melting and boiling points are much lower. But when we compare them to nonpolar covalent substances, polar covalent substances are usually higher because the molecules of polar covalent substances have positive and negative ends, and those positive and negative ends tend to attract the positive and negative ends of other molecules. So the negative end of molecule A might attract the positive end of molecule B, and that attraction tends to hold the molecules closer together. It keeps them from easily sliding, flying apart from each other, and that tends to keep them liquid and solid at slightly higher temperatures than the nonpolar covalent substances. So ionic substances have very high melting and boiling points. Covalent substances, we're going to say, have relatively medium to medium low boiling points, melting points. And then nonpolar covalent substances have low to very low boiling and melting points. So ionic substances, because of the high melting and boiling points, they're almost always solids at room temperature. Whereas polar covalent substances and nonpolar covalent substances, it's a little bit more complicated depending on how large or small the molecule is. But polar covalent substances are all, often liquids, like water, or gases. And then the same thing with nonpolar covalent substances. The larger ones tend to be liquids, and then the smaller ones tend to be gases at room temperature. Okay, so let's talk about solubility. If you take a sample of one of these substances and you put it in a solvent, does it dissolve? So ionic substances have fairly high solubility in polar covalent solvents. So things like water, ionic substances will dissolve in. However, their solubility tends to be very low in nonpolar solvents. Whereas the polar covalent molecules, they're kind of the same thing. They're kind of like the ionic ones. They have high solubility in ionic substances, and they don't have as low, but they're still relatively low solubility in nonpolar solvents. That's why, for example, water and oil don't mix. Oil is nonpolar and water is polar, and they tend not to dissolve in each other. Now, the nonpolar substances are the exact opposite. They're low solubility in polar solvents, and they have high solubility in nonpolar solvents. So again, oil, which is nonpolar, doesn't dissolve in water, which is polar. They have low solubility in each other. But if you took oil and gasoline and you mix those two together, they would dissolve in each other because they're both nonpolar. All right, Electrical conductivity. Now, as a solid, ionic substances don't have electrical conductivity because there's nothing to move around. Everything's locked in place. But if you melt them or you dissolve them, then they have very high electrical conductivity. There we go, solution. So anytime that you melt an ionic substance or you dissolve it, you'll get a relatively high electrical conductivity. Now, polar substances don't have the greatest electrical conductivity because there's not anything in them to actually move the charges around. If there's something dissolved in the polar substance, then they'll conduct electricity. Otherwise, it's very low. And the same with nonpolar solvents. Nonpolar solvents tend to have low electrical conductivity. Now, a word of caution about the polar solvents. A lot of students will say, well, water is a polar solvent and it conducts electricity. I know this just from my everyday life. But what you have to remember is that the water that you encounter in your everyday life is almost always a mixture. It almost always has stuff dissolved inside of it. And it's not the water that's conducting the electricity, it's the stuff that's dissolved inside of it that's conducting it. And you can easily test this by doing a conductivity test on distilled water. When you do that, if you do it in a clean beaker with a clean voltmeter, you'll find that distilled water has low to no electrical conductivity. All right. So I just left some space down here at the bottom if there were any other properties that I wanted to mention. I do have just a few things. Ionic substances, they tend to form crystal solids. Often white, not always white. They tend to be rather hard and brittle. And the reason for that is because when you smash a crystal, ionic crystal substance, a lot of times what you'll do is you'll just shift the ions one little bit, and once they shift a little, like one atom down, one ion down, you've got positive ions next to each other and negative ions next to each other, and they of course repel. So if you can just smash it and shift it down one ion like that, it'll pop right apart, and that results in this brittleness that you find with all these ionic substances. Now, polar and nonpolar covalent substances, it gets pretty crazy. A lot of things affect their properties, like the molecular weight of the substance and functional groups on the substance and things like that. But they range anywhere. Actually, I'm going to kind of erase this a little bit here. They range anywhere from, if they are solid at room temperature, they're often soft solids at room temperature, and that would be things like plastics or even things like sugar, which is a covalent substance and is a pretty soft solid at room temperature. Now I know you probably don't think of sugar as soft, but if you think about how easy it is to crush it or mush it up, or what it's like when it's powdered sugar, it's pretty soft. Not as soft as plastic, but softer still than ionic things. Another thing about polar and nonpolar covalent substances is that they can sometimes form these giant networks. They're called covalent networks, and if the atoms tend to bond into a covalent network, that results in an extremely hard substance. Some of the hardest substances in the world are covalent networks. And this would be things like sand, which is a covalent network consisting of oxygen and silicon. Diamond is a covalent network of just carbon atoms, and everyone knows how hard diamond is. So there you go. Make sure that you have locked in your melon how these three bonding types shake out with some of these properties. Try to keep these kind of miscellaneous things in your head too that I mentioned at the end, and you should be all set for the quiz that you've got to take. So as always, if you have any questions, feel free to ask in class, and thank you for watching.